The first factoring method that we typically learn is factoring out the greatest common factor, or the GCF. And what this is, effectively, is it's the opposite of using the distributive property to multiply. So I want to start by looking at a multiplication problem that uses the distributive property so we can see how factoring out the GCF is related. So let's look at a multiplication problem. Let's look at 3x squared times x cubed minus 5x plus 2. We know that if we want to multiply this, we're going to have to take the 3x squared and we're going to have to distribute it to all of the terms inside the parentheses. So we'll start by multiplying 3x squared times x cubed. That gives us 3x to the 5th. Then we're subtracting, so we have minus 3x squared times 5x gives us 15x cubed. And then we have plus 3x squared times 2 is 6x squared. What we've just done here is we have multiplied by using the distributive property. But if we're going to undo this, if we want to go in the opposite direction, this involves factoring, and specifically factoring out the GCF. Now, we're going to do this problem twice, factoring this. We're going to do it the slow way, where we show all of our work and we see where everything comes from. And then we're going to look at the slightly quicker way. So let's start. We are going to factor 3x to the 5th minus 15x cubed plus 6x squared. Now, what we're going to do is we're going to take each of these terms one at a time, looking at them separately, and we're going to factor them individually. So 3x to the 5th, 3 is prime, so we can't break it down. And x to the 5th is x times x times x times x times x. Now, if we look at negative 15x cubed, this is negative. And 15 factors down to 3 times 5. And x cubed is x times x times x. And then 6x squared, 6 can also be factored. It's 2 times 3, and x squared is x times x. So we look at these, and the first thing we want to ask ourselves is, what do these three terms all have in common as far as factors go? We notice all of them have 3 as a factor, and then they also have some x's. And in particular, each one of them has at least 2 factors of x. So if we look to see what they have in common, this is called the greatest common factor. What they have in common, they've got a 3 and they've got 2 factors of x in common. And so 3 times x is 3x squared. And you'll notice that this 3x squared is the same as the 3x squared we had in the original problem. So if we want to undo this distributive property, if we want to undo the multiplication, which is what we're doing when we're factoring, the way to figure out what goes out front is by looking for the greatest common factor, the biggest thing that all of the terms have in common. Now, we also, if we're looking back, we've got this x cubed minus 5x plus 2. And if we ask ourselves where that comes from, we can look at the leftovers here. In the 3x to the 5th, we're left with 3 factors of x, and x times x gives us our x cubed. Then if we look at the next term, the leftovers are going to be negative 5x, so that's going to be minus 5x. And then in our last term here, the only thing that's left over is the 2, so that's going to be positive plus 2. And this is exactly what we had up here, so we know it's correct. And so in parentheses here, the things that we're going to always put will be the leftovers. the things that we're left over with after we've pulled out those common factors. And so when we factor 3x to the fifth minus 15x cubed plus 6x squared, we end up with 3x squared times the quantity x cubed minus 5x plus 2. So this is how we can find and factor out the greatest common factor, but we don't actually want to have to write all of this out every time. We're going to want to get to the point where we can do most of this in our heads pretty quickly, because this will eventually be one step in a larger problem. So I want to look at this again in a different way to see how we can get this answer without writing all of these things out. So we still have 3x to the fifth minus 15x cubed plus 6x squared. Now when we're looking for the greatest common factor, we're looking for the largest thing that all of these terms are divisible by. So we can start actually by looking at the coefficients, 3, negative 15, and 6. And we can ask ourselves, what's the biggest whole number that all of those can be divided by? And we recognize that all of those are multiples of 3, and there aren't any larger numbers that those are all multiples of. So 3 is going to be the numerical part of our greatest common factor. Then we can look at the variable parts. We've got x to the fifth, x cubed, and x squared. And we can see that all of those contain an x squared, or 2 factors of x. So that's also going to be a part of our GCF. And so in total, our GCF is 3x squared, which is what we saw earlier the first time we did this. Now, to figure out what the leftovers are going to be, we need to take each of these original terms and divide them by 3x squared. So if we take 3x to the fifth and we divide out 3x squared, or we pull out 3x squared, we get rid of the 3. And if we start off with x to the fifth and we pull out an x squared, that still leaves us with 3 factors of x, or x cubed. Then, because it's a subtraction, we're going to have minus. Now, if we take 15x cubed and we pull out a 3x squared, 15 divided by 3 leaves us with 5. And then x cubed divided by x squared leaves us just with a single factor of x. And then we've got plus 6x squared divided by 3x squared just leaves us with 2. And so we end up getting the same answer without having to write out all of the factorizations of each of the terms. Now this might seem a little bit intimidating the first time you do it, but once you get practice, this becomes a lot easier, and we can get to the point where we can factor out the GCF without having to show all of our work here.